So by this way means by using the stock law we can easily determine the what is the percent, what is the rate of creaming of our preparation, right? So so our creaming is a means it is the upward movement of our dispersed globules to form a thick layer at the surface of our emulsion. If we or we see this kind of thing, that time we will call it our preparation become or became cream, right? So Stock is a was a scientist, and he was discover this formula, right? So on the basis of or by using this equation or formula we can determine the rate of creaming, right? So so as I said, that is v means there is a v, the meaning of v, that is the rate of creaming. Then small r, that is the radius of our globules, means whatever the globules disperse into the continuous phase, means whether it is oil globules or water globules, right? Means our disperse phase become a fine globules, and that will be distributed throughout the continuous phase. Okay, the fine the radius of our fine globules, small r. Then small d1, that is the density of disperse phase. We know that is a two phase, that is disperse and continuous. D1 means the density of our disperse phase. Then d2 is density of our continuous phase. Then g means gravitational constant, it is a constant value. It is a constant value, we can change it, right? It is a given constant value. Then small n is the viscosity of dispersion media. Viscosity means viscosity of our dispersion media means our continuous phase, whether it is oil or water, right? Depend on the preparation, whether what kind of preparation we have to prepare, right? So small n is the viscosity of dispersion media. So as I said, that is viscosity play an important role, right? So you know all, right? Then there is also some reason, means by which our preparation become creamy, right? So there is a radius of our globules, right? Radius of our globules means there is a we know that is if our globule size are large, that time we will get a large radius, right? If our particle size is small, that time we will get a small radius, right? Means the radius is depend on the size of our globules, right? So let's see rate of creaming. The rate of creaming is directly proportional to the radius of our globules. Equal to means if the rate of creaming increases, right, or the radius of our globules is increases, that time ultimately the rate of creaming or percent of our creaming will be increases, right? And when the radius will increase, if our globule size is large, means in simple language, if our globule size large, that time chances of increasing the rate of creaming also, right? Means the rate of creaming is directly proportional to the radius of our globules. If the radius decreases or radius less radius of globules, that time our rate of creaming also decreases, right? And if our rate of creaming is less, that time the chances of creaming also less. So by this way the rate of our creaming depend on the radius of our globules, right? Suppose you know that is a coarse emulsion, that is the coarse emulsion contain a large size of globules, right? Large size of our globules, right? That is the globule size. We already studied the range of our globules, right? That is the 0.25 micron to 25 micron, right? So this is the range of our globules. If the globule size higher, that is between the 20 to 25 micron, that time we will consider our preparation is a coarse emulsion. And coarse emulsion are very easily converted to the cream form, right? Means the coarse emulsion has a large globules, right? Coarse emulsion contain a large globules, and if the large and ultimately the large globules, we will get a higher radius, right? And the radius also become higher, ultimately our rate of creaming become higher. So by this way the radius plays a very important role for minimizing the rate of creaming or increasing the rate of creaming, right? So as like that is a large globule size, more will be creaming. As I said, that is increasing the globule size, creaming will be more. And then instead of smaller the globule size, ultimately the less will be creaming, right? If you want to minimize the rate of creaming, that time we will go for minimizing the size of minimizing the size of our globules. If the globule size become um, less, ultimately the radius will be less, right? And we will get a less rate of creaming, right? So by this way the over radius of globules plays a very important role for minimizing or decreasing the rate of creaming, right? Then smaller globule size form a slow creaming than large globules. So there is also one statement says that if we minimize this globule size, and we note that that is various kind of machines are there by which we can easily minimize or decrease the size of our globules. That is a homogenizer. We was discussed in our previous lecture also, right? That is a homogenizer, hand homogenizer or Silverson mixer homogenizer or colloidal mills are using for the minimizing or reducing the size of our globules, right? Suppose we made a large globe coarse type of our emulsion, right? And we know that coarse kind of emulsion become very easily cream, right? That's why. And for the treating of or minimizing the rate of creaming, we use the homogenizer or any hand homogenizer or any kind of colloidal mill for the reduction of size of globules, right? Means the rate of creaming is higher in the large globule size of emulsion, right? And the rate of creaming is less in the smaller globule size of our emulsion, right? Slow in this smaller globule size of emulsion, the creaming are happen but very slowly, right? That's why this statement says that smaller globule size form a slow creaming than the large globule size, right? So we understand here that is for minimizing the creaming or for the slow creaming, we have to minimize the globule size of large globules, right? So there is also solution also there, that is we already said that is solution, that is creaming can reduce by reducing the size of globules by the passing through the homogenizer. So as I said, that is homogenizer are generally used for the reducing the size of our globules, right? So ultimately if we reduce the size of globules, we will be also minimize the we can minimize the rate of our creaming, right? If the rate of creaming become less, that time we will get a more stability, right? We will get a more stability, or we will get a more stable preparation, right? So by this way the our radius plays a very important role. The radius of our globule size or radius of our globules plays a very important role for creaming, right? So afterward, that is our second reason for the formation of creaming, that is the difference in the density of dispersed and continuous phase, right? Density of our, so as simply you understand that you can understand, that is density means you just now you consider the weight of our dispersed phase and continuous phase. You know that all things has some weight. So density of dispersed phase and density of our continuous phase, right? Means weight of our dispersed phase and weight of our continuous phase. So the difference, there is a given one suitable difference, that difference should be between that right? So that is a if the difference of density of dispersed or continuous phase are higher, that time the chances of forming the more cream, right? And if the difference is less, that time the chances of happening less creaming. So this statement are said that is the rate of creaming depend on the difference between density of dispersed and continuous phase. Our continuous phase whether it is oil or water, on our dispersed phase whether it is oil or water, right? And the difference plays a very important role, that is a density, means weight of our dispersed phase and continuous phase are also, it is responsible for the formation of creaming, right? So that's a greater difference, more creaming. If our difference of or weight of our dispersed phase and continuous phase are the difference of our dispersed phase and continuous phase are more, that time the chances of occurring creaming are more, right? Means suppose we use the 10 ml continuous phase and we use the 5 ml dispersed phase, that time there is a difference of density, weight of our two phase are very higher, right? Greater, that time there is chances of occurring the creaming. And in case of our difference less, that is that we suppose we add the 10 ml continuous phase and 9 ml or 8 ml dispersed phase, that time there is a density, that is a weight of our two phase, the difference of that two phase, that is small, right? That time have chances of occurring less creaming, right? That is the greater difference, that is a more creaming, right? So difference can be reduced but it not required therapeutically, right? Means there is a one statement says that is we can minimize the creaming by lowering the difference of density of our two phase, right? But this difference is not very crucial for us because it is not required for therapeutically, right? So it not required therapeutically, means if we will change that difference, that time there is no impact for our therapeutic effect of our preparation. That is therapeutic effect means our pharmacological effect, right? Means there is intention to taking any kind of doses from, that is it should cure our disease or disease condition, right? Or so that this statement says that is the difference can be reduced but it not required therapeutically. We can minimize the difference, right? We can minimize the difference of density of our two phase, right? But that is not important, right? We can minimize the difference of density of our two preparation, right? For the only for the minimizing the rate of our creaming, right? And that difference are not affect to the our therapeutic effect of our preparation, right? So it is crucial for us, right? Right, so it is crucial for us. Then our, so by this way our difference in density of our two phase are responsible for minimizing or decreasing the our rate of creaming, right? So our remaining reason or remaining point for the creaming we will discuss in our next lecture, right? Along with there is a small portion are remaining, that is a small portion are remaining, that is the viscosity of our dispersion media and storage. And our third reason, that is a phase inversion and small portion from the storage of our emulsion, right? And one difference between. So these things we will, or this topic we will discuss in our next lecture. So it is enough for today. I suggest that you should carefully read it and carefully understand it. If you have any doubt or any question, you can discuss in our group, right? And I will try for solving your problems, right? So thank you for giving your valuable time. Thank you.